Essentially, the ENVI Modeler is used to create custom task-based workflows within ENVI. It combines the power of the ENVI API with a simple and intuitive user interface to help you build workflows without any knowledge of ENVI programming or IDL. Today, I'm going to walk you through the basic tools and concepts of using the ENVI Modeler so that you can get started on making some cool models yourself. So first, let's talk about what makes up a model. A model consists of two primary elements, nodes and connectors. A node is a basic building block, such as an input file, task, or other operation, whereas a connector is a gray line that connects nodes to one another via their input and output parameters. Nodes can consist of basic nodes, as you see here, or tasks. To add a node to your model, double-click and choose anything from your dataset. Task nodes are displayed as yellow boxes, while basic nodes are displayed as boxes of various colors. If a node accepts an input, it has an arrow on the left side. If it creates an output, it has an arrow on the right side. A node can have arrows on both sides. To connect nodes with one another, move the cursor over an arrow in a node until the plus icon appears. Click and drag to draw a line to the appropriate arrow on another node. If you attempt to make a connection that is not valid, no solid line will appear. Tasks are processing operations that act on input data. The task list includes all of the ENVI tasks that are available in the current ENVI session. You can click this button here to display the task parameters dialog. If a model contains a task that ENVI does not recognize, the task node is colored red. For example, the RPC orthorectification using DSM from dense image matching task requires the ENVI photogrammetry module. If this module has not been installed, the task is colored red to indicate it is undefined and the model will not run. You can add a file or dataset node to a model, then connect it to a task node. A file node represents one or more files on disk that contain data that ENVI can read. So any file on your computer that you can find, use the file open. Use the dataset node, as I did before, to specify data that is already open in your ENVI environment. You can also define input data by using the task parameters dialog I previously showed you. By clicking this button, you can put your input data in directly from there. By using the Add Array of Values node to a model to specify an array of numbers or strings as inputs to a task. For example shown here, suppose that you want to run an isodata classification task on multiple times on different iteration values each time and compare them. Provide an array of integers using an array of values node, seen here, then connect it to an iterator node. The iterator node defines a set of items and iterates them as inputs into the next task. Next, the modeler has the ability to add multiple file or dataset nodes to a task that requires multiple inputs. An example of this I will show you now is create subrecs from vector task, which accepts both an input raster and an input vector. So if I come up to dataset, I choose my raster, as well as my vector. To find my create subrecs from vector task, I can come over to my task and type in create. If we scroll through, we find create subrecs from vector. We add both of our inputs into the first arrow, and as you can see, the modeler is smart enough to pick up which is a vector and which is a raster. Next, I'll show you how we can use meta tasks. To organize a model when it contains many elements, you can create a meta task that encloses multiple task nodes. As you can see here, Las Vegas Urban Sprawl is not a task that ships with ENVI, so we created a meta task for it. A meta task is essentially a task that contains other tasks. It contains JSON code that combines multiple tasks using ENVI task code. You can generate a meta task and save it as a .task file on disk or publish it so that it becomes available for use with other ENVI tasks. The way we did this was created a workflow, as we see here, and then generated a meta task from that. We published this task and called it Las Vegas Urban Sprawl, and from there it was added to our task list and then included in our new workflow. Another powerful feature of the ENVI Modeler is the ability to batch process multiple datasets without requiring you to write a programming script. By using the iterator node we just talked about, we're going to add 16 rasters as well as previously defined regions of interest into a classification and upload that into our view. As you can see, we added 16 rasters here, as well as our original raster that we created our regions of interest on, and our regions of interest as our inputs. We use the iterator node to gather the 16 rasters and push those into our classification. Another great tool to use is the aggregator tool. The aggregator node collects multiple items and adds them to an array. Place the aggregator node in the appropriate location in the model and add input and output connectors to the iterator node. Here is a complex example that performs temporal classification. Instead of classifying a single image based on spectral signatures, the model calculates a normalized different vegetation index for multiple images, assembles the results into a multi-image band, and creates a classification image of the NDVI results over time. This is an example of how the aggregator node can be used in combination with the iterator node. Next, once you have set up your model, it is always good to validate your model before you run. After you have added the desired nodes and connectors, you are ready to run your model. Validation is necessary to ensure that the required input parameters are present, that all parameter values are valid, and that all connections and output parameters are configured properly. You can validate the model before running it by selecting Code, Validate Model. Validation problems include errors and warnings. If your model has errors, you will not be able to run the model. Warnings are recommendations that you should note, but you can still run the model. To run a model, click the Run button or select Code Run Model. Nodes are colored green when the model successfully completes those steps. If an error occurs, the model stops on the offending node colored bright yellow and issues an error message with the details of the problem. The ability to highlight nodes as you run a model to show progress requires an ENVI and IDL license. It is also good to note that if you have a geospatial services framework installed, you can run a model on a GSF server or an ARC server if that's what you have on your system. So it looks like our model finished running. To add your server, you can come up to server and click add server, whether it's GSF, ARC, or whatever you use in your environment. So as this model finished running, we pushed our results not only into our data manager but our view. As you can see, we have 3 different iterations of our ISO data classification. Also, if we open up our data manager, we have all 3 as well as our vector and raster input files. This button here centers your model so that it's nice and clean, as well as the automatic layout that lays it out in a different pattern if the one you have does not suit your needs. Another great tool is the Generate IDL code for a model. From the ENVI Modeler menu, come up to Code and Generate IDL program. Note, you must have an ENVI and IDL license to run this feature, and the IDL code is displayed in a new program window, as seen here. From here, you can save your IDL program to a .pro file. You can run the program, or you can create a tool from the model that you can add to your ENVI toolbox by Create Extension. In Create ENVI Extension dialog, provide a name for the tool and the extension name. This is what we did previously with the Las Vegas Urban Sprawl metatask. If IDL is not your programming language, but prefer Python, you can also generate a Python program. To run the Python code that is generated, you must have Python, pip, and one of the following installed: ENVI PyEngine, ENVI Py for ArcGIS Pro, or ENVI Py for ArcMap. From here, you can save your program file to a .py, you can run your model, or you can configure the output directory of the Python program by clicking the Configure Task engine. When running a Python program, the results will not be displayed or added to the data manager in ENVI. All of the output rasters or vectors that are connected to a view or data manager node will be preserved in the outputs folder. Other intermediate files that are created will immediately be deleted upon running the program.